Exercise 12.6, question 14. Just some homework problems here. If x equals 2 is a double root of this polynomial, ax to the power of 4 minus 2x cubed minus 8x plus 16 equals 0, find the value of a and the sum of the other two roots. Now, if it's a double root, remember when we were doing, that means that you've got, if you factorized it, you'd have x minus 2, x minus 2. In other words, two of the roots are 2 and 2, and we'll let the other roots be alpha and beta. Remember, it's always good practice. Notice we're missing the x squared term here. So it is good practice on the side to write down what your a is, b, c, d, e, which are your coefficients of each term in the polynomial, so that you don't mess up, okay? So we do want to find the sum of the other two roots. So let's just start with doing, now look, when you've got polynomials and they're quartics, you would only do sum of roots 2 at a time and 3 at a time if you absolutely needed to, because it does get quite long. So always start off with sum of roots 1 at a time, and also do product of roots, because remember we've only got two unknowns here, alpha and beta, right? So if your roots are 2 to alpha beta, you can do your sum of roots, which is, if you write sum of roots, that just means 1 at a time, okay? Sum of roots 1 at a time. Remember, sum of roots 1 at a time is minus b on a. 2 plus 2 plus alpha plus beta is minus b on a, which is, you've got 4 plus alpha plus beta is negative 2 on a. So 4 plus alpha plus beta is 2 on a. That is your first equation. You could rearrange it if you wanted to make it alpha plus beta is 2 over a minus 4. All right. Then you would also look at your product of roots. I wouldn't start doing sum of roots 2 at a time and 3 at a time. It's just that there are too many combinations. I think for 2 at a time you have 6 combinations. And for 3 at a time, you only have 4 combinations, but because each one gets missed out. But if you can just get away with doing, start off with 1 at a time, 2 at a time, I actually think we have to do 3 at a time anyway. But, yeah. All right, so sum of roots 1 at a time gives us that. Product of roots, okay, always go with those first, gives us alpha times beta is 4 on a. Now, let's just look at what we've got. We've got this, which has got 3 unknowns. This has got 3 unknowns. Guess what? You have to do another equation. See, if you've got 3 unknowns, remember we do simultaneous equations with 3 unknowns, used 3 equations. So if you do have 3 unknowns, there's no other way around it. You have to do 3 equations. Sorry. That's got 3 unknowns, alpha, beta, A. We need another equation. You could do, look, 3 at a time is easier than 2 at a time, you know, because the reason it's easier is because there's only 4 combinations as opposed to 6 combinations with 2 at a time. See, if I do sum of roots 3 at a time, I just miss 1 root every single time. Does that make sense? So that is easier than doing the 6 combinations of 2 at a time. All right, so you can do your 2 2s with the alpha, the 2 2s with the beta, a 2, and so you just got to go back up here because you've got 2 2 alpha beta. You've got to make sure you combine them all properly. So you've got 2 2 alpha, 2 2 beta, but then you've got this 2 with the alpha beta, then you've got this 2 with the alpha beta. So that's why we've got that, which is 4 alpha plus 4 beta plus 4 alpha beta. Remember, sum of roots 3 at a time, we go minus b on a, c on a, minus d on a. That's minus d on a, which gives us 8 on a. And now we've got 3 equations, and you can, you'll get this. And that simplifies nicely. Alpha plus beta is 2 on a. Then you're going to have to start manipulating and putting some equations into others. See it on the one screen. We've got these 3 equations. So if we substitute alpha plus beta is 2 on a minus 4 in here, and if we substitute this alpha times beta into here, which is 4 on a, we're going to only be left with a's only as the unknown. So what we're doing is substituting equation 1 and equation 2 into equation 3. And the reason we do that is that we eliminate all the alpha and betas and we find out what a is. So we're going to replace this alpha plus beta with 2 over a minus 4, plus we're going to replace this alpha beta with 4 on a equals 2 on a. And now we can just multiply through by a. Multiply through by a. And you will get 2 minus 4a plus 4 equals 2. We get that 4a is 4. A is 1. And now you can just substitute a is 1 into any equation you want. Actually, it'll have to be into both equations 1 and 2. Are you okay with that? And then we can work out... Oh, was the question to work out... What was the question? To work out alpha and beta? The sum of the other two roots, wasn't it? Yeah, so we would just substitute a equals 1, into equation 1, because that gives me the sum of the other two roots. If you wanted the product of the other two roots, you would substitute it into equation 2. Okay, substitute a equals 1 into equation 1. Sorry, I've just got this other stuff underneath. Gives me alpha plus beta is 2 over 1 minus 4, which is negative 2. And like I said, if you wanted the product of the other two roots, and if you wanted alpha times beta, that would just be 4 over a, which is 4 over 1, which is 4. So the sum of the other two roots is negative 2, and the product of the other two roots is 4, but they didn't want the product. 19, exercise 12.6, solve, there's a typo in the book, solve 12x cubed minus 4x squared minus 3x plus 1 equals 0 if the sum of two of its roots is 0. So you just let the roots be alpha, negative alpha, and beta. Okay, what are you going to do? Sum of roots. Just try one at a time and product, and then go to 2 at a time if you need it. So let's just go the sum of roots. If it's just sum of roots 1 at a time, you don't need to write 1 at a time. So it's alpha plus negative alpha, which is minus alpha, plus beta. Doesn't that equal minus b on a? What's that? Beta is? You've already worked it out. That was quick. So it's negative negative 4, which is 4 on 12, which is a third. So solve it. Oh, sorry, we're trying to solve for x. So one of the roots is a third. All right, what are we going to do? Product of roots? Let's do our product of roots. Product of roots is alpha times negative alpha times beta. Isn't that negative d on a? Now we know what beta is as well. So let's go negative alpha squared beta. Negative d on a, we've got a, b, c, d. D is 1. So it's negative 1/12. All good? We're going to substitute beta is a third. And we get negative alpha squared times a third equals negative 1/12. Let's keep going. You can get rid of the negatives on each side now if you swap sides. So alpha squared over 3 equals 1/12. In other words, alpha squared is 3 over 12 is a quarter. What does alpha have to be? Alpha is plus or minus a half. Now you know how we've got alpha and minus alpha? Alpha is a half. Negative alpha is negative a half. So there's your two, that's your alpha and minus alpha there. See, if alpha is a half, then negative alpha is negative half. If alpha is negative a half, then negative alpha is a half. So that gives you your alpha and your negative alpha. So therefore the roots are, the roots of your equation are a half, negative a half, and a third. Now when it says solve the equation, you're finding the roots of the equation. That's your solution. That's what x is. So if I substituted x is a half into my original polynomial, I should get 0. If I substitute x is negative a half, I should get 0. Let's just check. So that's what solve means, find the roots. So checking, 12x cubed minus 4x squared minus 3x plus 1 is 0. If I put p of a half, I should get 0. That's 12, a half cubed is an eighth. So that's 12 on 8 minus 4 on a half squared is 4, minus 3 over 2 plus 1. What's that? Isn't that that's 1.5 minus 1.5 is 0, negative 1 plus 1, that's 0. So the roots are your solutions. Okay? Negative half will work as well, and a third should work as well. When you're asked to solve this, you're asked to find the values of x. You know how we know that there are 3 values that you're supposed to get because it's a cubic? Those 3 values are the roots of the equation. They are your alpha, negative alpha, and beta. They are the solutions. Just showing you, if I did happen to substitute these in one at a time, I would get 0 each time because they're my roots. Okay?